Hello, Math 2. This is the second part of our lesson on factoring and intercept form. So there's 6 graphs to look at on your paper if you have your notes, and each of those functions is shown in both standard form and factored form. And I want you to look at them and identify the x and y intercepts from each graph and make some observations about the connection between the equations and the intercepts. So our first graph, if you wrote down the intercepts, you probably wrote down that they are located at -3 and -1. Right here at -3, here at -1. And the y-intercept is at +3. And let's see, I'll just pick another one to bring out here. This one has a y-intercept of 4 and an x-intercept of -2. And let's see, one more. So on your paper, you have 6 of these, but I'm just going to pull out a few. Okay, so on this one, we have x-intercepts at -3, +3, and the y-intercept is at -9. So something that you might observe when you are looking at this is that the x-intercepts are the zeros of the factored form. So here's our x-intercept, and if we look at this factored form, it has the same factor repeated, so it only has one x-intercept. And the x-intercepts here correspond with the zeros of its factored form. And you might also, if you were thinking about the y-intercept and those equations, you might also notice that the y-intercept is found in the standard form of the function as the constant at the end. And that holds true for those other 3 graphs as well. I'm just showing 3 on my screen right now. So if we had an expression or quadratic that was x minus 9 and x plus 1, we would probably predict that it would have x-intercepts at 9 and +1. Now, to find the y-intercept, we could, one way we could think about it is by putting this equation into standard form. That would be x squared minus x minus 9x plus 9. So x squared minus 10x plus 9. And so we can see that that y-intercept is 9, or predict, I guess. And if we looked at a graph of this function, we would find that those predictions are true. So different forms of the quadratic function reveal different attributes of the graph. So the factored form helps us to easily identify the x-intercepts of the function. So if in factored form it's x minus p and x minus q, on the graph I will see those intercepts at p and q. Standard form helps us to know or see easily the y-intercept. So the y-intercept would be here at c. The vertex occurs exactly halfway between those x-intercepts. And we're going to talk more about the vertex in another lesson, but I just wanted to mention in this lesson that it is exactly halfway. So this distance here will be exactly the same as this distance here. And anytime your a value is negative, if that either of those, in either form, if you have an a that is negative, you're going to have that parabola reflected and opening downward. So different forms might be the same parabola. These are all different forms of the same parabola, but different forms are useful in different ways to reveal different attributes of the graph. So we're going to do an example here where we look at, we're given the standard form. We're going to factor it to put it into intercept form. And then we're going to sketch a rough graph of the function. So this is a little bit tricky one to factor. Anytime you see a number that is in front of the x, you want to think about if it might possibly be a common factor. So in this case, that -2 is a common factor. So we're going to factor this in 2 steps. We're going to first factor out the -2 from the trinomial, and then we'll break that trinomial up into its 2 factors. So on that first step, we're just factoring out a -2. We're unmultiplying, so you can think of it as dividing the coefficients by -2 to calculate them if you want to. So that first term, if we factor out a -2, it just leaves the x squared. If we factor a -2 from an 8, that is a -4x. And if we factor the -2 from the 24, that is a -12. So our trinomial that we're trying to factor is x squared minus 4x minus 12. And so we are going to start with that beginning x squared. So that means we need an x in each of our factors. The number 12 is a good one. 1 times 12, 2 times 6, and 3 times 4 are its factorizations. So we're trying to get a middle term of a -4. So I'm thinking we're going to use the 2 and the 6, with the 6 being negative. So -6 and a +2 here. And if you were factoring it and you wrote it like this with the x plus 2 first and the x minus 6 second, that's also fine. The order of the 2 factors doesn't matter. They just need to be the same factors. All right, so if our function has a factor of x minus 2, that means that one of its x-intercepts is going to be, that's like the worst 0 I ever wrote in my life. It's like a little 6. The x-intercepts are going to occur at -2 and at +6. So I'm going to mark those on my graph. And then I think you'll get a better shape if you kind of think about what's halfway in between. And halfway is going to be right here at 2. Now this parabola, if I think about it, in its original form, this coefficient is negative. So this is going to be a parabola that opens downward like so. So I'm going to just put the vertex up here. And I like to just put a vertex somewhere just because it helps me draw my shape better. But even then, sometimes my shape's not that great. Okay, so there's my parabola. We want to also just mark the y-intercept of our parabola. Y-intercept. Now the y-intercept we can get from standard form. And for this parabola, that y-intercept is 24. So I'm going to just mark that on the graph. The y-intercept does not tell you anything about the vertex. The y-intercept tells you where it crosses the y-axis. So in this case, I really want to write a 1 right there. Oh my goodness. In this case, it is definitely below the vertex. Vertex would be up above it. All right, so let's do one more example. I'm sorry. We're going to do 2 more examples where we kind of reverse that process. We're going to use the graph to write the equation in intercept and standard form. So in this one, to write the function in intercept form, we need to identify where the intercepts are occurring. So the intercepts are occurring at -2 and at +5. So each one of those corresponds with one of the factors of the function. X plus 2 and x minus 5 are the 2 factors of this graph, or this function. So we just need to put a y equal, and we have intercept form of our function. Now to get standard form, we just need to multiply out our intercept form. So x plus 2 times x minus 5 is x squared minus 5x plus 2x, and then minus 10 at the end. So if we combine those two like terms, we get x squared minus 3x minus 10. That's our function in standard form. So we've got intercept form right here, and we've got standard form right here. Once you have your standard form, a great idea, if you have your graph, is to check your y-intercept. We should see our y-intercept at -10, and it is indeed at -10. So that kind of gives us a little bit of confirmation that we've done our work correctly. So Another form that we have talked about last unit is vertex form. So when I look at this graph, you see how the intercepts are not at nice locations. You don't want to like estimate to put a graph into vertex form. If it does not have nice intercepts, you need a different strategy. Well, this one does have a really nice vertex right there at 2, -5. And since that vertex is such a nice point, we can write our equation in vertex form. This is the form that we used last unit, and we're going to use it occasionally this unit as well. Y equals a times x minus h squared plus k. So our stretch on this one is just going up 1, up 3, up 5 like our normal parabola pattern. So we could put a 1 for a, or we can just leave that blank. X minus 2 squared minus 5. So that gives us our vertex form of our parabola. To get standard form, we need to multiply this out. So remember that we talked about that squaring means to times it by itself. So we're going to times that x minus 2 by itself. But then don't forget, we also have this minus 5 at the end. So if we multiply this out, we get x squared minus 2x minus 2x, and then we have a plus 4. And then, of course, we do not want to lose or forget our minus 5. So if we combine up, and we've got a couple sets of terms we can combine here, our standard form is going to be x squared minus 4x, and 4 minus 5 is -1. So here is standard form of the equation. And again, you can always check your y-intercept to see if you got it right. And there it is at -1. We have our correct y-intercept. All right, that is it. So there is some practice that you can work on, or just talk to your teacher about what your assignment is. Thank you so much.